Hey folks, Mr. G here. We got another video for you today. Today we're going to be talking all about linear word problems. In particular, we're going to be looking at two different types related to numbers and shapes. Before we jump into examples, I wanted to remind you of some of the stuff that we did before spring break, because we actually did a lesson about word problems. There were notes on my website that talked about some tips for solving word problems. So these are two excerpts from the website. So if you haven't, check out the website notes. So some tips for solving word problems. Highlighting the question, so whether that's highlighting it through underlining or maybe you have a highlighter of your own, whatever it is, I really encourage you to do that. Next is to define a variable. Usually people like to use something like x for something you don't know or want to solve for. Once you have your variable, you want to try and set up an equation using the information that you highlighted beforehand and then solve. A reminder that you need an equation. That means there's an equals sign somewhere in order to solve it. The last step, and this is one that a lot of people miss out on, is to take whatever your x was and relate it back to what the question is actually asking for. So just because you solved x equals 3 doesn't mean the answer is 3. So make sure that you go back and always, if you can, check your answer. During that lesson, we also went over some word problem vocabulary. I'm not going to go through all of this here, but the notes are available on my website. If this looks confusing, please take a look. For this video, we're going to talk about word problems that involve shapes, so geometric shapes. So our first example is a rectangle with a perimeter of 8 centimeters. The width is 1 more than 3 times the length. Find the length and the width. We want to answer with reduced fractions. So like I told you, let's try and highlight some key information. We're told that the rectangle has a perimeter of 8 centimeters. Remember, perimeters all the way around, where the width is 1 more than 3 times the length. We want to find the length and the width, so we're actually going to have 2 answers for this question. So what we want to do next is try and define some variables. I'm going to start with the length. So we can call the length x if you like, or L. Now we know that the width is 3 times that length plus 1. So 1 more than 3 times the length is 3 times the length plus 1. So if we wanted to summarize this in a picture, this is what it would look like. If we want to find the perimeter, we have to add all of these sides together. So we would have to add all of our sides together. That's going to be equal to 8 centimeters. Now this is where the polynomial addition that we did last unit is going to come in handy. We can group some like terms together. So all of our x's and then all of our numbers on this side. So putting that all together, we get this. I'm going to move all the numbers onto the left-hand side by subtracting 2 from both sides. Finally, it's 8 times x. I have to divide by something. Since this is being multiplied together, we're going to divide by 8 to get rid of the 8 times our x. So we get x is 6 over 8, but we can reduce this by dividing the top and bottom by 2. We get 3 over 4. Now before you circle this and say you're done the question, remember that we want actually 2 answers. This is only our length. To find the width, we have to go back to the equation that we have for width, 3x plus 1. So we need to do 3x plus 1. We know x is 3 over 4. Remember, when we're multiplying fractions together, we multiply the tops, we multiply the bottoms. To add these two together, we need to turn this into a fraction with a denominator of 4. So 1 turns into 4 over 4. We can add the tops together, keeping our denominator the same. We get an answer of 13 over 4. So those are our 2 answers for the length and the width. This question isn't too hard to check. We know that the perimeter should be 8, so if we add 2 copies of each side, we should get 8. Since they all have a denominator of 4, it's not too hard to add them together. We add 3 plus 3 plus 13 plus 13 and get 32 over 4, which reduces to exactly 8, and we know we got the question right. Our second example is going to involve a different shape. It's going to involve triangles. So here's our second question, all about triangles. Let's highlight some important information. So we're told one angle is 1.7 times larger than another one, and that a third angle is 16.1 degrees smaller than one of our angles from before, and we want to find each angle. So in this case, there are 3 angles in a triangle, so there's going to be 3 answers. Let's define our variable. I'm going to say the first angle, we're going to call x, and now we can see what the second and third angle need to be. The second angle is 1.7 times larger. Times larger means we're multiplying. The third one, 16.1 degrees smaller, so this is going to be subtraction. For this particular question, I forgot to mention before, we're just going to answer to 1 decimal place if needed. So if this is our triangle here, and we have angle number 1, angle number 2, and angle number 3, the key piece of information you need to remember is that for a triangle, all of these angles added together equals 180 degrees. So let's use that, along with the information we have on the side here, to set up an equation. So this would be our equation, inserting our values for the first, second, and third angle. To help us get rid of these decimals, like we saw last week, what we want to do is multiply by a power of 10. In this case, we only have 1 decimal place, so we only need to multiply by 10 on both sides, and that includes everything on both sides to get rid of all these decimals. And there we go, all the decimals are gone. Again, we want to gather our like terms, like so, move our constant, our number, onto the other side by adding it, and then finally dividing by 37 on both sides to get our value for x. So we get our x value, which is, remember, the value of our first angle to be 53 degrees. But we need the other two angles. So let's take this and try and plug it into our other formulas. Our second angle was 1.7 times x, so 1.7 times 53, which comes out to 90.1 degrees. Our third angle was x minus 16.1 degrees, so 53 gives us an answer of 36.9 degrees. And there we go, those are our three angles. If you wanted to check, again, we can plug it back into our equation. We know that all of these added together should give us 180, so let's check it. So if we add all of these together, lo and behold, we get 180 degrees exactly. That concludes the first video. Stick around for the second one. Don't try any of the questions yet. I'd rather you go through all the examples, and then you can try some questions afterwards. See you then.